Okay, for question 72, we have the integral of this composite function. Now, automatically our substitution emerges from this. Let's look at this composite function and break it down. We have f, our outside function, in this case is sine of something. What is that something? The inside function g of t is 2 pi times t divided by capital T, don't mistake this with little t, capital T is a constant, minus alpha. And so this inside function is going to give us our substitution. Let's make our substitution. U is equal to 2 pi t divided by capital T minus alpha. Okay, now this function is going to be taken care of by the substitution, which means all we have to get rid of is dt. Okay, no problem. How do we do that? Same way as usual. du divided by dt is equal to, the alpha is a constant and it goes away. All we're left with is 2 pi divided by capital T. Now, we want dt isolated, and so I'm going to cross multiply that up here, and I'm going to take the 2 pi down here. Capital T goes up there through cross multiplication. The result is that we have t times du divided by 2 pi is equal to dt. Now that we have our replacement, we can start making our substitution. However, we need to find our new limit. How do we do that? Well, take the old limit, replace it in the change of variable equation in place of t, the variable t. So our new lower limit is going to be 2 pi times the old lower limit, which is 0, divided by capital T minus alpha. This is equal to negative alpha. And the upper limit is going to be 2 pi times the old upper limit, which is capital T divided by 2, this guy divided by capital T, minus alpha. T and T cancel out, 2 and 2 cancel out, and we have pi minus alpha as the upper limit. Let's put these in. We have negative alpha as the lower, pi minus alpha as the upper, and so we replace sine of u. Now dt gets replaced by du, and since t divided by 2 pi is a constant, we can place it out in front of the integral. Alright, what next? Well, this is a simple enough integration, so what I'm going to do is integrate it and get negative. Actually, I'm going to put the negative outside front because it's more simple. Cosine of u, and our limits are negative alpha and pi minus alpha. At this point, negative t divided by 2 pi, and inside my bracket I have cosine of pi minus alpha minus cosine of negative alpha. Once again, we use trigonometric identities to break up the cosine formula. We can express this as cosine pi cosine alpha plus sine pi sine alpha. And if you remember your odd and even functions, cosine looks like this, and on the other side is the exact same, and so cosine is an even function, which means cosine of negative alpha, or cos of negative x, is equal to cos of x. In our case, cos of negative alpha is equal to cos of alpha. Now, having made all these replacements, first I'm going to notice that sine of pi, or sine of 180 degrees, is equal to 0. As a result, this whole term goes away. All I'm left with is cosine of pi, which is equal to 1, so cosine of pi, this guy here, is equal to 1. So inside my bracket, I have 1 times cos alpha minus cos alpha, which is exactly 0. As a result, my answer